Good morning. Good morning. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, September 12, 2021, Sunday, your rest time. But I am still busy for disseminating whatever information I can about quality, safety, health, environment. And title of talk is Civil Field Engineering, Life, Quality Annexure, COVID-19, Safety, Health and Environment, Engineer's Role, Designs, Construction, Methods, Contracts, Organizations, Communication, Coordination, and why we should be behind quality of standard materials and works. Very important talk with very important issue because we we are having, being engineers, certain certifications of competencies, certain certifications of responsibilities at national level and at international level. These certificates tell everyone, you can say, these certificates tell everyone that person is quality one. Person is quality one. I mean to say, engineer is quality engineer. This is what this says. It's not simply title that would work. Title must be there, but it will be responsibility that will work towards society, towards nation building, and towards whole world. Quality is no. You can say what you can say. It's not privilege. It's right of people. Of course, it is privilege, but it's really fundamentally it's right of people, and it is responsibility of professionals, particularly those professionals who work in the field of engineering, and also for those professionals who do not work in field of engineering. If we don't respect quality, we don't respect safety, health and environment. This means we don't respect humanity. We don't respect nature. I am saying we don't respect nature because whatever materials we produce, whatever products we produce, all materials, all ingredients we get from nature. All ingredients, we do not have anything other than nature that helps us. All these resources, even human resources, are from nature, material resources, as well as all other resources. Natural agencies help everybody, help this world, this planet. We have to consider in overall perspective at a level which is beyond our reach. When I say engineering, engineering means serve people. Serve people using all these resources that nature has endowed on us for purpose of development, for purpose of making lives of people on earth better in every way, simultaneously keeping in view that natural balance, natural equilibrium, and we can say sustainability should not be impacted upon. Engineering is not what we think only, that have certain education in engineering and do it. It's not simply that. Engineering is life. That's why I always say engineering plus life. If there is life, there should be engineering. speaks something, life demands something. Life says, I have given myself to you, you preserve me, you care about me, or else you would suffer. I am nature, I am skies, I am earth, and you are there on earth. You have to take responsibility of earth because you are custodian of earth, you are user of earth, you are free without rent tenant of earth, you are a traveler on earth, you are, having all capacities to use my resources for your survival, for your you can say existence. This is what life says. Life is experienced. It cannot be considered a commodity. Life is highly respectable, but it should have quality. There are people who are very poor. There are people who are little poor. There are people who are middle class. There are people who are lower class. There are people who are highest class. This is all related to existence of economic conditions. Whatever economic conditions we have in every class, those conditions speak a volume of life. For someone, life, if one gets food, okay, I get food, it's okay for me. You can say birds, animals, they search only for the stomach fulfillment. They just look for, you can say, search for food, and that's it for them. They do not need for themselves. Maybe they need, but they don't claim that they need houses. They should have roof. It is human to provide, but if they get enough food, I think they sleep well. And this also applies to those two you can say poor people all over the world, who at least, if given food, they feel, okay, something I have got. If I get some roof for night, it will be okay for me. And there are people who think, oh, I have so much in my life, God has given me all this. I don't worry about anything. I have money, I have facilities, I have properties, I am rich man, I can do whatever I want. Everybody has requirements, everybody has its own ways. But what I say, all human are same, life is same. There should be no such difference, but it happens. Why does it happen? That's a point of concern we should worry about. That's why I say these certificates are valuable only if we respect these certificates, we honor what we do, how we do. Quality should be considered a must, I can say. If quality is not considered a must, whatever we do by ignoring quality, that shall be considered just a dust, must or dust. It is a responsibility in particular for all engineering community all over the world to initiate, to chart out, to follow and to maintain quality and safety. Though safety is separate discipline, but because safety is also very important for maintaining quality. Because if someone is not safe, say not safe on work, or you are not safe, you are not safe for some other reason, maybe you are sick, your health is bad, certainly one cannot concentrate on work. One cannot concentrate on quality of work because of disturbance of mind due to sickness. Therefore, upkeep of health is also too significant. If we cannot do that, well, I think we should insult ourselves. We should blame ourselves. If I have workers with me, they work for a project on which I do, it becomes my responsibility to look after them. Same way, it looks my responsibility to worry about quality and take its care. If I can't do that, this means either I am unsuitable for that job or I do a sin, I can say. I commit a sin if I can do it and I can't do it. I can do it, but I can't do it. And due to whatever reason, there could be many reasons for that, but I am not born for reasons. My profession is that you deliver quality product with every safety. Engineering is not it's not a device. It's not a device, I can say. Engineering can be considered a worship level. We go to temple, mosque, etc. to worship places and perform worship. I say, as far as engineering is concerned, it's more than worship. Because you are going to use all resources there. It's not simply worship resource. Every resource that nature has directly or indirectly provided to us. Human resource, equipment resource, material resource, technology resource. Human resources, of course, it's natural, but it is maintained. So we have to use that. Without human resource, we cannot do anything. Even if we have machines, we cannot do anything. Human resources natural. Machines are partly natural and partly processed by manufacturing, by technological use. And we can say that material resource is also in maximum cases natural, but it's also processed one. If we can just think this way, that engineering means, what its actual definition is, we have to use natural materials for development. And we should use optimally. We can not even waste those natural materials because no one has got any right to waste those materials. Why to waste those materials? These are God's given in a sense that earth was given, earth is given, earth is working because of power of God. We cannot see, but we can understand. I am living because of power of God. Everybody is living because of power of God. If my power is withdrawn from God, withdraws this power from my body, there is no way that I can live. This means my employer is God. You got my point. Yes, there is one representative on earth for my employment. That is also by God. That's also given by God. But ultimately, this earth belongs to God. So God is responsible for this earth. This means God is responsible for each and every activity, each and every material, whatever we have on this earth. That is ownership. That's ownership of God. And we cannot interfere in ownership and responsibility of God. We can support, we can say, okay, what you instruct us we shall do. You are our employer. And if you say no, we should get payment, I think then we are mistaken, because we already get payment. We get payment for whatever work. It may be money payment or it may be payment in some other form. We get fruits, we get crops, we get food, we get good body, we get natural support, rain, wind, skies, sunlight. We get everything that's required for this problem and we don't pay them. We don't pay them. It's not even, you can say, subsidy. It's total subsidy, total grant, free of cost. Just use it and enjoy this. This means indirectly we are getting payment and we are not returning anything to nature. That's what I define life. Life is temporary, but until it is temporary, it is important. Nobody can stay on earth more than life cycle of that person. That is defined by nature, which is secret. One has to come and one has to go. That is basic principle of life, and that is considered life. But even this, that is very important. We should not worry about something else, but we should worry about not to abuse not to abuse by whatever process worth of this material, these resources that we have. And that's what I say, engineers' roles are attracted. Engineers' roles are involved. Engineers' roles are involved in development of this world. We cannot develop this world without technology. We cannot develop this world without contribution by engineers and ultimate contribution by society of whatever nation. Every nation has different level of development, a different level of status. Though status is not very important, but life is very important. Three basic elements that we have: food, cloth, and housing. These are very important, we know. Some have good level, some don't have good level. Point is not that. Point is quality. Quality, we should keep off all ailments. We should be safe. We should be healthy. And we should have good environment. And it is only idle talk I am making, but it should be converted to reality. I am very concerned now that we are not finding quality levels. Safety is one part. I am just putting this file off because it's no more required now. Talk is over. So I putting this file off. I'll put this file off. So what I say that again and again I show you same file. It doesn't make a much big difference because quality and safety have to move together. And without quality, we can say without quality nothing can move. That's also true. Also I we call it in Hindi Gunavatta. Gun means merit. What is merit of material we produce? And what is merit and demerit? What are merits and demerits of something we get from nature that we can observe? We can't change that. We can amend that, but we cannot originally do it. So we can say character of some merits and demerits of some material, merits and demerits of some person, human, and we should worry about that our works, our persons, our people, our human resources should be safe during work. They should not be pushed to accidents by imagination or by ignorance or by whatever you can say. Accidents should be avoided at any cost. Everybody says zero accident, but accidents do happen. It happens. Well, I explain a lot for that. Quality required everywhere. This is my understanding and your understanding. It is required, but how much it is affected, that is the point. In our life, everything is quality, everything is safety, every activity in life requires quality, and engineering is part of life. Without that, we cannot do anything. We understand that. Merit is required. Merit means quality, good quality is required in every work. And without security, without surety, we should not work. That also we know. Now I will not go further on this because we should worry about, you can say, we should worry about quality maintenance, quality achievements, and we should worry about everything as such. Otherwise, we shall suffer. We shall not be professional. Even if we are professional, we won't be able to consider ourselves professional. That much. That was, yeah, it is that list. What I at Siddharth COVID-19, of course, people are trying to hide information about COVID-19 these days. Every country is trying to, you can say, divert to economy. Even when COVID is working, and they are trying to suppress news, and it's very clear. No country is giving right news, including ours. They are trying to say economy is more important than health. It means is that. Well, it's human. Human shall learn by time. I have seen that world is more serious about economy, but not serious about health of people. Economy is fixed. You should know. Maybe people don't accept this. What is talking every day? There's change. That's okay. There is change, but in a sense, economy is not that you do something on this. Economy is not my ownership. Economy cannot be upgraded or downgraded. Because elementary economics, basic wealth of earth, okay, you have hydrogen and oxygen, but from where do you get this hydrogen and oxygen? At that point, that person comes back to nature. That it is nature who gives us hydrogen and oxygen. So if nature gives you hydrogen and oxygen, then what's yours? Point stands. What is yours then? If you ask same thing for something else, that I can manufacture air, I don't understand that some scientists would claim that. That's what I say. Material on earth, material within lithosphere is fixed in quantity, and we do not know all materials, what all materials are up to center of earth, and what is quantity of those materials, what are quantities of those materials. Why don't you think this way? That we are living on earth, it's part of solar system, which is a part of universe. We have fixed materials, we have fixed quantity of everything in earth, and nothing can be added to these quantities. Even if you use these materials results in something which can be called waste, that shall take millions of years to convert it to something else. Human scientists, human beings haven't been able to produce something original. As I give example of water, it can be example of whatever you consider. We cannot change human body. We cannot generate human body without you can say intermingling of male and female. We cannot do anything if our body is not biological. It's only biology of body, microbiology of body that is responsible to some way for circulation of generations. Same way, nature is responsible for materials forms and material changes. Of course, it takes millions and millions of years. It took millions or thousands of years for changing fossil fuel to crude oil, fossils to crude oils, and crude oil to petroleum products and their bioproducts to plastics, methylene, ethylene. But we say this is for us because it belongs to earth. Alright, earth belongs to you, you are a passenger, and you can use which materials, but it does not mean that you disturb whole material and use that. Material is fixed, quantity is fixed. You cannot. Yeah, you may escalate cost. Just like I say, I have a house. It was built up 20 years back. It was at that time this was cost. Now this cost is this much. There is escalation. There is capital gain. That's true. But even if there is capital gain, don't forget quantity of materials permanently included on this building are same. All materials quantities are same. We have not done anything else on these quantities. We can say cost is double, 3 times, 4 times. It is due to something else. It is due to inflation. It is due to that our currency is falling every day. That can be related to that one. But we should not forget quantities of materials that we included in structure. These cannot change. That's main point. Our wealth is fixed, except agricultural field, where every year, every season we have varying quantities. Sometimes all crops are spoiled. Sometimes something is spoiled, sometimes it is preserved. There you can say that we can grow something new, but that too doesn't stand in our control because of nature of that. We cannot do anything. Can someone produce banana? Can somebody produce apple without nature? That cannot happen. We cannot even generate without following process of God, process of nature, and that's true. So we should not think of economy always, because this is economy that has caused frictions among societies, that has caused level of corruption everywhere. Even if you die for money, even if you go behind money for all times, forever, you cannot find solutions. Had money been that important, then we had were controlled by now COVID-19, but we failed. And I think all those people who used to run behind money, who used to run behind power, behind earth power, behind nations power, behind other powers, those people have also lost these lives. All riches, all middle class, all higher professionals, even doctors and nurses, which are called number one servers, number one service providers, number one professionals, they have also lost lives. This means life is important for everyone, and wealth is also important, but to some extent. If you use your life just to gathering money, storing money, but what's the purpose of that money, you may not know. You say, I have invested this money there and here. Means you just want to make money out of money. Development cannot be done just making money out of money. Development can be done. I am talking development, total development. I am not talking construction development. Development cannot be affected just by thinking we have money. Determination, will, use of materials, resources, all should be very, very clear, contemplated, and development is necessary, but we know that we are very confined, we are very limited in that way. So we should take care of that. Never confine only to money. Now I was talking about list. Team has to check something. I just refresh. It is only a list for reference. It is not that you have to follow this. Whatever project you have, whatever work you have, it has its own ways, it has its own subheads, its own requirements, and that audit should be considered, should be conducted accordingly. Now we are talking of facilities plant. Facilities plants means major plants, or you can say just we speak in general language that facilities, or you can say refining product, or you can say if you go a little below, then at least from level of refining, you will find other projects where byproducts from refining are used. It's for that purpose, but I just want to disseminate my information about audit, what is function of audit. This just you can say an example I'm taking from certain source, that equipment must be installed there when you are going to do audit. In operation standard, not in project standard, that you can say industry, we call it oil industry, energy industry, whatever you can call it, equipment installed already in accordance with approved area classification. There may be flare fence installed because of flare. There can be handrails and toe boards installed. You can say adequate and unobstructed easels, walkways and headrooms available, minimum 2 stairways or ladders for all operations platforms. And also there may be many devices where pressure relief devices installed, maybe many vessels or many equipment or many other areas where pressure is involved. To avoid injury to personnel from hot or toxic releases. Atmospheric vents properly positioned with respect to prevailing winds. Fireproofing installed, blast resistant walls and blowout panels installed where enclosed equipment has potential danger of explosion, where you can say explosion can happen anytime. So we have to protect that from blast resistant construction. Adequate dikes installed. Ventilation installed in building containing flammable material. Uninterruptible power supply, which we call UPS, installed from protection viewpoint. Then double valve installed in cryogenic services. They are low temperature, very very low temperature, minus temperature you can say, is involved. At least we have to keep one valve which should not freeze while service valve freezes. Then we can take care using that valve, standby valve like this, which should take care even if it is cryogenic atmosphere in that material or in that tunnel of, in that pipeline of through which this material flows, should not be chilled, should not be frozen. Ladders, ready and safe access, particularly during an emergency, to valve instruments, switch gears and equipment. That access is also very important. That is ready and safe access, particularly during an emergency, to valves, instruments, switch gear and equipment. Ladders and stairways located away from potentially hazardous areas. Emergency lighting installed. Adequate fire and gas detection system installed. Adequate fire water system installed. Battery limit block walls installed. We had talked about what is battery limit. That is, you can something differentiating between this, you can say this responsibility division to other moving parts of equipment, HSE showers and eye wash stations installed and supplied. Electric ground, electric lockout, fire lookout. Now, I would teach the 11th September. I took these files. Where this file has gone? Electric. Maybe somewhere missing, I think. No, it's not missing. So I would say GHE lighting arresters. This is lighting arresters. So I should say electric lighting arresters. I should write rather, so that it is or same electric light. I should say electric light arresters. Electric. Okay. Systems. These are there. We will just go through references, and this is from Wikipedia. It says in electrical engineering, ground or earth, both are same. Its reference point are measured. A common written path for electric current or a direct physical connection to earth. Direct physical connection to earth. That's called earthing. Electrical electrical circuits may be connected to ground. Electrical circuits may be connected to ground for several reasons. Exposed conductive parts of electrical equipment are connected to ground, so that failures of internal insulation which create dangerous voltages on parts, which could be a shock hazard, shall trigger protective mechanisms in circuit such as fuses or circuit breakers, which turn off power. I repeat, this is technical sentence and it should be understood properly. It should be understood properly. We cannot take chance because it is important activity, and that is earth. Electrical circuits may be connected to ground for several reasons. Exposed conductive parts means in equipment, whatever conductive parts are there, electrical conductive parts I'm talking of. Exposed conductive parts of electrical equipment are connected to ground. You can see that here. shall trigger shall trigger protective mechanism. They will trigger start protective mechanisms in circuit, such as fuses, or circuit breakers. These would triggered. This will be triggered for purpose of protection, and that is fuses or circuit breakers, which turn off power. Which turn off power. In electric power, distribution systems, a protective earth, that we say PE. In electric power distribution systems, a protective earth PE conductor is an essential part of safety provided by earthing system. What is that? PE, protective earth. In electric power distribution systems, a protective earth PE conductor is an essential part of safety provided by earthing system. What is written? Let us see a typical earthing electrode. Here, if you can see this picture, a typical earthing electron left of gray pipe. This one is here. This is here, consisting of a conductive rod. This is conductive rod driven into ground at a home in Australia. Most electrical codes specify that insulation on protective earthing, that's PE conductors, must be a distinctive color or color combination, not used for any other purpose. Okay, now we say connection to ground. Connection to ground also limits build up of static electricity. It limits build up of static electricity when handling flammable products or electrostatic sensitive devices. But it says connection to ground also limits build up of static electricity when handling flammable products or electrostatic sensitive devices. In some telegraph and power transmission circuits, ground itself can be used as one conductor of circuit, saving cost of installing a separate return ability. An electrical ground system should have an appropriate current carrying capacity to serve as an adequate zero voltage reference level. Zero voltage reference level. What it says, an electrical ground system should have an appropriate current carrying capacity or capability to serve as an adequate zero voltage reference level. In electronic circuit theory, a ground is usually idealized as an infinite source or sink for charge. Which can absorb an unlimited amount of current without changing its potential. Where a real ground connection has a significant resistance. has a significant resistance, approximation of zero potential is no longer valid. Stray voltages or earth potential rise effects will occur. Stray voltages or earth potential rise effects shall occur, which may create noise in signals or produce an electric shock hazards if large enough. So this para is very much technical. I read it again so that if something misses can be clarified, can be cleared. For measurement purposes, earth serves as a reasonably constant potential reference against which other potentials can be measured. An electrical ground system should have an appropriate current carrying potential, current carrying capability to serve as an adequate zero voltage reference level. In electronic circuit theory, a ground is usually idealized as an infinite source or sink for charge, which can absorb an unlimited amount of current without changing its potential. Where a real ground connection has a significant resistance, where a real ground connection has a significant resistance, approximation of zero potential is no longer valid. Stray voltages or earth potential rise effects shall occur, which may create noise in signals or produce an electric shock hazard if large enough. Use of term ground or earth is so common in electrical and electronics applications that circuits in portable electronic devices as cell phones and media players, as well as circuits in vehicles, may be spoken of as having a ground or chases ground connection without any actual connection to earth, despite common being a more appropriate term for such a connection. This is usually a large conductor attached to one side of power supply, such as ground plan, on a printed circuit board, which serves as common return path for current from many different components. So now I am not having this history. Now let us go some history also just for our reference. It's not essential, but let's go just to know what happened in past. It's a matter of just half a minute to study. So read this, doesn't matter, Long distance electromagnetic telegraph systems from 1820 onwards used two or more wires to carry signal and return currents. It was discovered by German scientist Carl August Stanhel in 1836 to 1837 that ground could be used as return path to complete circuit, making return wire unnecessary. Stanhel was not first to do this, but was not aware of earlier experimental work and was first to do it on a service-in-service telegraph, thus making principle known to telegraph engineers generally. However, there were problems with this system, exemplified by transcontinental telegraph line constructed in 1861 by Western Union Company between St. Joseph, Missouri and Sacramento, California. During dry weather, ground connection often developed in high resistance, requiring water to be poured on ground rod to enable telegraph to work or phones to ring. In late 19th century, when telephony began to replace telegraphy, it was found that currents in earth induced by power systems, electric railways, other telephone and telegraph circuits, and natural sources including lightning caused unacceptable interference in audio signals and two-wire or metallic circuit system was reintroduced around 1883. Now building wiring, we are going to building wiring installation. Building wiring is very important. We all know it. What is building wiring? We use it every day, even in daytime we use it, at night time we use it. And this is a part of building, it cannot be removed. It's very important, for without electricity we cannot live. Building wiring installation, electrical power distribution, electrical power distribution system, electrical power distribution systems are often connected to earth ground. Electrical power distribution systems are often connected to earth ground to limit voltage that can appear on distribution circuits. A distribution system insulated from earth ground may attain a high potential due to transient voltages caused by static electricity or 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 accidental contact with higher potential circuits. An earth ground connection of system dissipates such potentials and limits rise in voltage of grounded system. I read again, it's also technical. Electric power distribution system that's in our homes or elsewhere are often connected to earth ground to limit voltage that can appear on distribution circuits means on our distribution board. Within that, a distribution system insulated from earth, insulated means if it is not connected to earth, a distribution system insulated from earth ground may attain a high potential if there is no earthing. I mean to say, distribution system insulated from earth ground may attain a high potential due to transient voltages caused by static electricity or accidental contact with higher potential circuits. An earth ground connection of system dissipates such potentials and limits rise in voltage of grounded system. In a mains electricity, AC power, we can say mains electricity, AC power, alternating current power, wiring installation, the term ground conductor typically refers to two different conductors or conductor systems as listed below. Now what are those two? One is, now say, equipment bonding conductors or equipment ground conductors, EGC, equipment ground conductors, provide a low impedance path between normally non-current carrying metallic parts of equipment, non-current carrying metallic parts of equipment, and one of conductors of that electrical system source. What it says, equipment ground conductors provide a low impedance path between normally non-current carrying metallic parts of equipment and one of conductors of that electrical system source. Electrical system source and equipment non-metallic parts, connection between two, says impedance of path, provide a low impedance path between normally non-current carrying metallic parts of equipment and one of conductors of that electrical system source. If now it exposed metal parts, if exposed metal parts should become energized, fault it's called, if exposed metal parts should become energized, such as by a frayed or damaged insulator. In case these are energized by chance, or you can say clearing disconnecting fault. It says if exposed metal parts should become energized should become realize fault such as by frayed or damaged insulator. It creates a short circuit. It creates a short circuit causing overcurrent device, circuit breaker or fuse to open, clearing disconnecting fault. If exposed metal parts should become energized, such as by a frayed or damaged insulator, it creates a short circuit causing overcurrent device, that is circuit breaker or fuse to open, clearing fault. It's important to note this action occurs regardless of whether there is a connection to physical ground. It's important to note that this action occurs regardless of whether there is a connection to physical ground, that's earth. Earth itself has no role in this fault clearing process. Earth has no role in this fault clearing process, since current must return to its source. However, sources are very frequently connected to physical ground. Sources are very frequently connected to physical ground, that's earth. And by bonding, interconnecting, you can say, by bonding all exposed non-current carrying metal objects together, by bonding all exposed non-current carrying metal objects together and to other metallic objects such as pipes or structural steel, they should remain near same voltage potential, thus reducing chance of a shock. This is especially important in bathrooms where one may be in contact with several different metallic systems, such as supply and drain pipes and appliance frames. When a system needs to be connected to physical ground or earth, equipment bonding conductor also becomes grounding electrode conductor. A grounding electrode conductor, what is that? This was equipment bonding conductor, equipment ground conductor. Now it is ground electrode conductor. Ground electrode conductor. This is a photo of metal water pipe used as grounding electrode. Grounding electrode conductor. Grounding electrode conductors GEC is used to connect system grounded, or that is neutral conductor, used to connect system grounded conductor or equipment to grounding a electrode or a point on grounding electrode system. This is called system grounding, and most electrical systems are required to be grounded. US NES and UK BS 7671 list systems that are required to be grounded. According to NEC, purpose of connecting an electrical system to physical ground or earth is to limit voltage imposed by lightning events and contact with higher voltage lines. That is, according to NEC, purpose of connecting an electrical system to physical ground is to limit voltage imposed by lightning events and contact with higher voltage lines. In past, water supply pipes were used as grounding electrodes, but due to increased use of plastic pipes, which are poor conductors, use of an actual grounding electrode is required. This type of ground applies to radio antennas and to lightning protection systems. Permanently installed electrical equipment, unless not required to, has permanently connected grounding conductors. Permanently installed electrical equipment has permanently connected grounding conductors. Portable electrical devices with metal cases. Portable electrical devices with metal cases may have them connected to earth ground by a pin or a attachment plug. Size of power grounding conductors is usually regulated by local or national wiring regulations. Bonding. Strictly speaking, terms grounding or earthing are meant to refer to an electrical connection to ground or earth. Bonding is practice of intentionally electrically connecting. Bonding is practice of intentionally electrical connecting metals items not designed to carry electricity. This brings all bonded items to same electrical potential as protection from electrical shock. Bonded items can then be connected to ground to eliminate foreign voltage. Today, bonding is, strictly speaking, terms grounding or earthing are meant to refer to an electrical connection to ground or earth. Means we have to connect electrical connections to ground or earth for purpose of grounding or earthing. Now, bonding is practice of intentionally electrically connecting metallic items not designed to carry electricity. This brings all bonded items to same electrical potential as protection from electrical shock. Bonded items can then be connected to ground to eliminate foreign voltage. Earthing systems. Okay. In electricity supply systems, an earthing or grounding system defines electrical potential of conductors relative to that of Earth's conductive surface. Choice of earthing system has implications for safety and electromagnetic compatibility of power supply. Electromagnetic compatibility of power supply regulations for earthing systems vary considerably between different countries. A functional earth connection serves more than protecting against electrical shock. As such a connection may carry current during normal operation of a device. Such devices include surge suppression, electromagnetic compatibility filters, some types of antennas, and various measurement instruments. Generally, protective earth system is also used as a functional earth, though this requires care. Impedance grounding. This was one which was, earthing systems. We are talking of impedance grounding. Impedance grounding. Distribution power systems. Distribution power systems may be solidly grounded. Distribution power systems may be solidly grounded with one circuit conductor directly connected to earth, grounding electrode system. Distribution power systems may be solidly grounded with one circuit conductor directly connected to earth, an earth grounding electrode system. Alternatively, some amount of electrical impedance may be connected between distribution system and ground to limit current that can flow to earth. Impedance may be a resistor or an inductor coil. In a high impedance ground system, fault current is limited to few amperes. Exact values depend on voltage class of system. A low impedance grounded system shall permit several hundred amperes to flow on a fault. A large solidly grounded distribution system may have thousands of amperes of ground fault current. This is also a very technical statement. Let us read again. Distribution power systems may be solidly grounded with one circuit conductor directly connected to earth grounding electrode system. Otherwise, we can say alternatively, some amount of electrical impedance may be connected between distribution system and ground to limit current that can flow to earth. Impedance may be a resistor or an inductor coil. In a high impedance ground system, fault current is limited to a few amperes. Exact values depend on voltage class of system. A low impedance grounded system shall permit several hundred amperes of flow on a fault. A large solidly grounded distribution system may have thousands of amperes of ground fault current. Now, in a polyphase AC system, an artificial neutral grounding system may be used. Although no phase conductor is directly connected to ground. A specially constructed transformer, a zigzag transformer, blocks power frequency current from flowing to earth. Can say a specially constructed transformer blocks power frequency current from flowing to earth, but allows leakage or transient current to flow to ground. This is a polyphase AC system. Polyphase, 3 phases, more phases, not single phase. Polyphase AC system, an artificial neutral grounding system may be used. Although no phase conductor is directly connected to ground, a specially constructed transformer blocks power frequency current from flowing to earth, but allows leakage or transient current to flow to ground. Low resistance grounding system use a neutral grounding resistor NGR to limit fault current to 25 ampere or greater. Low resistance grounding systems shall have a time rating, say 10 seconds. That indicates how long resistor can carry fault current before overheating. Means low resistance grounding systems have a time rating 10 seconds, say, that indicates how long Register can carry fault current before overheating. A ground fault protection, a ground fault protection relay must trip breaker to protect circuit break before overheating of register occurs. A ground fault protection relay must trip breaker to protect circuit before overheating of register occurs. High resistance ground. This was low resistance. Now we are saying low resistance is says low resistance ground system shall have time rating 10 seconds. Say that indicates how long resistor can carry fault current before overheating. A ground fault protection relay must trip breaker to protect circuit before overheating of resistor occurs. High resistance grounding. High resistance. High resistance grounding systems use an NGR, again neutral grounding resistor, to limit fault current to 25 ampere or less. They have a continuous rating and are designed to operate with a single ground fault. This means that system shall not immediately trip on first ground fault. If second ground fault occurs, a ground fault protection relay must trip breaker to protect circuit. On HRG system, a sensing register is used to continuously monitor system continuity. If an open circuit is detected due to a broken weld on NGR, if an open circuit is detected, monitoring device shall sense voltage through sensing register and trip breaker. System could continue, can say, without a sensing register, system would continue to operate without ground protection, since an open circuit condition would mask ground fault and transient over voltage could occur. So what I say, high resistance grounding HRG system use NGR to limit fault current to 25 ampere or less. They have a continuous rating and are designed to operate with a single ground fault. This means that system shall not immediately trip on first ground fault. If a second ground fault occurs, a ground fault protection relay must trip breaker to protect circuit. On HRG, high resistance grounding system, a sensing register is used to continuously monitor system continuity. If an open circuit is detected due to a broken valve on NGR, without a sensing register, system could continue to operate without ground protection, since an open circuit condition would mask a ground fault and transient over voltage could occur. Ungrounded system, ungrounded systems. Ungrounded systems, where danger of electric shock is high. Special ungrounded power systems may be used to minimize possible leakage current to ground. Examples of such installations include patient care areas in hospitals, where medical equipment is directly connected to a patient and must not permit any power line current to pass into patient's body. Example of such installations include patient care areas in hospital, where medical equipment is directly connected to patient and must not permit any power line current to pass into patient's body. Medical systems include monitoring devices to warn of any increase in leakage current. On wet construction sites or in shipyards, isolation transformers may be provided so that a fault in a power tool or its cable does not expose users to shock hazards. Circuits used to feed sensitive audio video production. Circuits used to feed sensitive audio video production equipment or measurement instruments may be fed from an isolated, ungrounded technical power system to limit injection of noise from power system. Now power transmission. Power transmission. In single wire earth system or in single wire earth return, we can say SWER, single wire earth return, an electrical distribution system, AC electrical distribution systems. Costs are saved by using just a single high voltage conductor for power grid. Says, okay. In single wire earth, a AC electrical distribution system, costs are saved by using just a single high voltage conductor for power grid. While routing AC return current through earth, this system is mostly used in rural areas where large earth currents will not otherwise cause hazards. AC electrical distribution system, that is SWER, single wire earth return, costs are saved by using just a single high voltage conductor for power grid, while routing AC return current through earth, this system is mostly used. Some high voltage direct current, HVDC, high voltage direct current power transmission systems use ground as second conductor. This is especially common in schemes with submarine cables. As seawater is a good conductor, buried grounding electrodes are used to make connection to earth. Site of these electrodes must be chosen carefully to prevent electrochemical corrosion on underground structures. So I read again. This is some high voltage direct current, HVDC, power transmission systems use ground as second conductor. This is especially common in schemes with submarine cables, as seawater is a good conductor. Buried grounding electrodes are used to make connection to earth. The site of these electrodes must be chosen carefully to prevent electrochemical corrosion on underground structures. A particular concern in design of electrical substations is earth potential rise. Earth potential rise. When very large fault occurs, when very large fault currents are injected, into earth, area around point of injection may rise to a high potential with respect to points distant from it. This is due to limited finite conductivity of layers of soil. This is due to limited finite conductivity of layers of soil in earth of substation from it in substation. Gradient of voltage. Gradient of voltage, change in voltage across distance to injection point, may be so high that 2 points on ground may be at significantly different. May be so high, gradient of voltage may be so high that 2 points on ground may be at significantly different potentials. This gradient creates a hazard to anyone standing on earth in an area of electrical substation that is sufficiently insulated from ground. Pipes, rails or communication wires entering a substation may see different ground potentials inside and outside substation, creating a dangerous touch voltage for unsuspecting persons who might touch those pipes, rails or wires. This problem is alleviated by creating a low impedance equipotential bonding plane installed in accordance with IEEE within substation. This plane eliminating voltage gradient and ensures that fault is cleared within 3 voltage cycles. I just repeat this one, it's a very important one, though I have understood. Yes, those who are not able to pick up, let them listen again. A particular concern in design of electrical substations is earth potential rise. When very large faults currents are injected into earth, area around point of injection may rise to a high potential with respect to points distant from it. This is due to limited finite conductivity of layers of soil in earth substation. Gradient of voltage, a change in voltage across distance to injection point, may be so high that 2 points on ground may be at significantly different potentials. This gradient creates a hazard to whosoever is standing on earth in that area of electrical substation that is insufficiently insulated from ground. Again, gradient of voltage may be so high that 2 points on ground may be at significantly different potentials. This gradient creates a hazard to anyone standing on earth in an area of electrical substation that is insufficiently insulated from ground. Pipes, rails or communication wires entering substation may see different voltage ground potentials inside and outside substation, creating a dangerous touch voltage for unsuspecting persons who might touch those pipes, nails, rails or wires. This problem is alleviated by creating a low impedance. Say, pipes, rails or communications wires entering a substation may see different ground potentials inside and outside substation, creating a dangerous touch voltage for unsuspecting persons who might touch those pipes, rails or wires. This problem is alleviated by creating a low impedance equipotential bonding plane installed in accordance with IE80 within substation. This plane eliminates voltage gradient, and what we have to do to alleviate this problem is alleviated by creating a low impedance equipotential bonding plane installed in accordance with IEAT within substation. This plane eliminates voltage gradients and ensures that fault is cleared within 3 voltage cycles. Electronics. Electronics. Signals. Signal grounds serve as return path. Signal grounds serve as return paths for signals and power at extra low voltages, less than 50 volts. Within equipment and on signal interconnections between equipment. Within equipment and on signal interconnections between equipment. Many electronic designs feature a single return. Many electronic designs feature a single return that acts as a reference for all signals. Power and signal grounds often get connected, usually through metal case of equipment. Designers of printed circuit boards may take care in layout of electronic systems so that high power or rapidly switching currents in one part of a system do not inject noise into low level sensitive parts of a system due to some common impedance in grounding traces of layout. Here are ground signals. You can see this is signal ground, arrow with this triangle, a kind of arrow, and this is chases with this hatch, and earth is like this, it's called ground signals. Now again I read this, I think signal grounds serve as return paths for signals and power at extra low voltages, less than about 50 volt. Within equipment and on signal interconnections between equipment, within equipment and on signal interconnection between equipment. Many electronic designs feature a single return. Many electronic designs feature a single return that acts as a reference for all signals. Power and signal grounds often get connected. Power and signal grounds often get connected, usually through metal case of equipment. Designers of printed circuit boards must take care in layout of electronic systems so that high power or rapidly switching currents in one part of a system do not inject noise into low level sensitive parts of a system due to some common impedance in grounding traces of layout. Circuit, ground versus earth. Circuit, ground versus earth. Voltage is defined as difference of electric potentials. What is definition of voltage? Voltage is defined as difference of electric potentials between points in an electric field. Voltage is defined as difference of electric potentials between points in an electric field. A voltmeter is used to measure potential difference between some points and a reference point. A voltmeter is used to measure potential difference between some point and a reference point. This common reference point is denoted ground. This common reference point is denoted ground and considered to have zero potential. Signals are defined with respect to signal ground. Signals are defined with respect to signal ground, which may be connected to a power ground. A system where system ground is not connected to another circuit. A system where system ground is not connected to another circuit or to earth in which there may still be AC coupling between those circuits. It is often referred to as floating ground or double insulated. I repeat, circuit ground versus earth. Circuit ground versus earth. Voltage is defined as difference of electrical potentials between points in an electrical field. A voltmeter is used to measure potential difference between some point and reference point. This common reference point is denoted as ground and considered to have zero potential. Signals are defined with respect to signal ground, which may be connected to power ground, a system where system ground is not connected to power to another circuit, or earth, a system where system ground is not connected to another circuit or earth, in which there may still be AC coupling between those circuits. It is often referred to as floating ground or double insulated. I think I need some minutes. Functional grounds. We may take some time to read this matter. Read this, give me a few minutes. I'll be back. Right? Just a minute. So 1 hour I think it's about 1 hour and a half hour. So let's take 5 minutes. So, functional grounds, we say it's called functional grounds, we have said. So we can say here some devices, functional grounds. What is functional grounds is, let us say, some devices require a connection to mass of earth. Some devices require a connection to mass of earth to function correctly. Some devices require a connection to mass of earth to function correctly, as distinct from purely protective role. Such a connection is known as functional earth. For example, some long wavelength antenna structures. Some long wavelength antenna structures require a functional earth connection, which generally should not be indiscriminately connected to supply. Protective earth. For example, some long wavelength antenna structures require a functional earth connection, which generally should not be indiscriminately connected to supply protective earth. As introduction of transmitted radio frequencies into electrical distribution network is both illegal and potentially dangerous. Reason is, what is the reason for that? Says that, for example, some long wavelength antenna structure required functional earth connection, which generally should not be indiscriminately connected to supply protective earth, as introduction of transmitted radio frequencies into electrical distribution system or network is both illegal and potentially dangerous. Because of this separation, a purely functional ground should not normally be relied upon to perform a protective function. To avoid accidents, such functional grounds are normally wired in white or cream cable and not green or green-yellow. Now, separating low signal ground from a noisy ground. Separating low signal ground from a noisy ground. In television stations, recording studios, and other installations where signal quality is critical, a special signal ground known as technical ground or technical earth, spatial earth, and audio earth is often installed to prevent ground loops. This is basically same provision as an AC power ground, but no general appliance ground wires are allowed any connection to it, as they may carry electrical interference. For example, only audio equipment is connected to technical ground in a recording studio. In most cases, studios' metal equipment racks are all joined together. Studios' metal equipment racks are all joined together with heavy copper cables or flattened copper tubing or bus bars. In most cases, studios' metal equipment racks are all joined together with heavy copper cables or flattened copper tubing or bus bars, and similar connections are made to technical ground. Great care is taken that no general chassis grounded appliances are placed on racks. Great care is taken that no general chassis grounded appliances are placed on racks, as a single AC ground connection to technical ground will destroy its effectiveness. For particularly demanding applications, main technical ground may consist of a heavy copper pipe, if necessary, fitted by drilling through several concrete floors. such that all technical grounds may be connected by shortest possible path to a grounding rod in basement. For particularly demanding applications, main technical ground may consist of a heavy copper pipe, if necessary, fitted by drilling through several concrete floors, such that all technical grounds may be connected by shortest possible path to a grounding rod in basement. Radio antennas. Certain types of radio antennas or their feed lines require a connection to ground. Certain types of radio antennas require a connection to ground. Since radio frequencies of current in radio antennas are far higher than 50 or 60 Hz frequency of power line, radio grounding systems use different principles from AC power grounding. Third wire safety grounds in AC utility building wiring were not designed for and cannot be used for this purpose. Third wire safety ground in AC utility building wiring were not designed for and cannot be used for this purpose. Long utility ground wires have high impedance at certain frequencies. In case of a transmitter, RF current flowing through ground wires can radiate radio frequency interference. RF radio frequency current flow through ground wires can radiate radio frequency interference and induce hazardous voltages on grounded metal parts of other appliances. So separate ground systems are used. Monopole. Monopole antennas operating at lower frequencies. Monopole antennas operating at lower frequency below 20 MHz use earth as part of antenna. As a conductive plane to reflect radio waves. These include T and inverted L antennas, umbrella antenna, and masked radiator used by AM radio stations. Feed line from transmitter is connected between antenna and ground, so it requires grounding earthing system under antenna to make contact with soil to collect return current. Feed line from transmitter is connected between antenna and ground, so it requires a grounding earthing system under antenna to make contact with soil to collect return current. In lower power transmitters and radio receivers, ground connection can be as simple as one of more metal rods or stakes driven into earth, or an electrical connection to a building's metal water piping which extends into earth. However, in transmitting antennas, ground system carries full output current of transmitter. So resistance of an inadequate ground contact can be major loss of transmitter power. Ground system functions as a capacitor plate to receive displacement current from antenna and return it to ground side of transmitter's feed line. So it's preferably located directly under antenna. Medium to high power transmitters usually have an extensive ground system consisting of bare copper cables. Medium to high power transmitters usually have an extensive ground system consisting of bare copper cables buried in earth under antenna to lower resistance, since for omnidirectional antennas used on these bands, Earth currents travel radially towards ground point from all directions. Grounding system usually consists of a radial pattern of buried cables extending outward under antenna in all directions, connected together to ground side or transmitter feed line at a terminal next to base of antenna. Transmitter power lost. Transmitter power lost in ground resistance and transmitter power loss in ground resistance, and so efficiency of antenna depends on soil conductivity. This varies, this varies widely. Marshy grounds or ponds, particularly salt water, provide lowest resistance ground, while dry rocky or sandy soil are highest. Power loss per square meter in ground is proportional to square of transmitter current. Density flowing in earth. Current density and power dissipated increases closer one gets to ground. Current density and power dissipated increases closer one gets to ground. Terminal at base of antenna. So radial ground system can be thought of as providing a higher conductivity medium, copper, for ground current to flow through in parts of ground carrying high current density to reduce power losses. Design. A standard ground system widely used for mast radiator broadcasting antennas operating in MF and LF bands, medium frequency and low frequency bands, consisting of 120 equally spaced buried radial ground wires, 120 equally spaced buried radial ground wires extending out 1/4 of a wavelength, 0.25 lambda, 90 electrical degrees from antenna. Number 8 to 10 gauge soft drawn copper wire is typically used, buried 4 to 10 inches deep for AM broadcast band antennas. This requires a circular land area extending from mast 40s, that is 47 to 136 meters. This is usually planted with grass which is kept mowed short, as tall grass can increase power loss. So this is kept mowed short, as tall grass can increase power loss in certain circumstances. If land area available is too limited for such long radials, they can in many cases be replaced by greater number of shorter radials or a smaller number of longer radials. In transmitting antennas, a second cause of power wastage is dielectric power losses of electric field displacement current of antenna passing through earth to reach ground wires. For antennas near a half wavelength high, 180 electrical degrees, antenna has a voltage maximum antinode. Antenna has a voltage maximum antinode near its base, which results in strong electric fields in earth above ground wires near mast where displacement current enters ground. To reduce this loss, these antennas often use a conductive copper ground screen under antenna connected to buried ground wires, either laying on ground or elevated a few feet to shield ground from electric field. In few cases where rock or sandy soil has too high a resistance for a buried ground, a counterpoise is used. This is a radial network of wires similar to that in buried ground system, but lying on surface or suspended a few feet above ground. It acts as a capacitor plate, capacitively, capacitively coupling feed line to conductive layers of earth. Electrically short antennas. Electrically short antennas, title is, at lower frequencies, resistance of ground system is a more critical factor. At lower frequencies, resistance of ground system is a more critical factor because of small radiation resistance of antenna. In low frequency and very low frequency bands, construction height limitations require that electrically short antennas be used. Shorter than fundamental resonant length of 1/4 of wavelength, lambda over 4. Lambda is wavelength. A quarter wave monopole has a radiation resistance of ground around 25 to 36 ohms. Below lambda over 4, resistance decreases with square of ratio of height to wavelength. Power fed to an antenna is split. Power fed to an antenna is split between radiation resistance, which represents power emitted as radio waves, desired function of antenna, and ohmic resistance of ground system, which results in power wasted as heat. Power wasted as heat. As wavelength gets longer in relation to antenna height, radiation resistance of antenna decreases, so ground resistance constitutes a larger proportion of input resistance of antenna and consumes more of transmitter power. Antenna in VLF band, very low F bands, often have a resistance of less than 1 ohm, and even with extremely low resistance ground systems, 50% to 90% of transmitter power may be wasted in ground system. Lightning protection system. Lightning protection system. Lightning protection system. Lightning protection systems are designed to mitigate effects of lighting through connection to extensive ground system that provide a large surface area connection to earth. Large areas required to dissipate high current of a lightning strike without damaging system conductors by excess heat. Since lightning strikes are pulses of energy with very high frequency components, grounding systems for lighting protection tend to use short straight runs of conductors to reduce self-inductance and skin effect. I repeat, lighting protection system. Lightning protection systems are designed to mitigate effects of lighting through connection to extensive grounding system that provide a large surface area connection to earth. Large areas required to dissipate high current of lightning strike without damaging system conductors by excess heat. Since lightning strikes are pulses of energy with very high frequency components. Lightning strikes are pulses of energy with very high frequency components. Grounding systems for lightning protection tend to use short straight runs of conductors to reduce self-inductance and skin effect. Very complicated paragraph. Lightning protection systems are designed to mitigate effects of lightning through connection to extensive grounding system that provide a large surface area connection to earth. Large area is required to dissipate high current of lightning strike without damaging system conductors by excess heat. Since lightning strikes are pulses of energy with very high frequency components, grounding systems for lightning protection tend to use short straight runs of conductors to reduce self inductance and skin effect. Ground earth mat. Ground earth mat. In an electrical substation, let me just minute, please. So, sorry, just a minute. I'm saying that in an electric substation, we are talking of electrical substation. In an electrical substation, a ground mat is a mesh. A ground mat is a mesh of conductive material. In an electrical substation, a ground mat is a mesh of conductive material installed at places where a person would stand to operate a switch or other apparatus. It's bonded to local supporting metal structures and to handle of switchgear so that operator shall not be exposed to a high differential voltage due to fault in substation. You say bus bars are shown here. Bus bars are used for ground conductors in high current circuits, and these are bus bars. You can say, here are that bus bars. In an electric substation, a ground mat is mesh of conductive materials installed at places where a person would stand to operate a switch or other apparatus. It's bonded to local supporting metal structures and to handle of switchgear so that operator shall not be exposed to a high differential voltage due to fault in substation. In vicinity of electrostatic sensitive devices, a ground mat or grounding mat is used to ground static electricity generated by people and moving equipment. There are two types used in static control: static dissipative mats and conductive mats. A static dissipative mat that rests on conductive surface. A static dissipative mat that rests on a conductive surface, commonly case in military facilities, are typically made of 3 layers, 3 ply with static dissipative vinyl layers. 3 layers with static dissipative vinyl layers surrounding a conductive substrate which is electrically attached to ground. For commercial uses, static dissipative rubber mats are traditionally used, that are made of 2 layers with a tough solder resistant top static dissipative layer that makes them last longer than vinyl mats, and a conductive rubber bottom. What is that? Again, you see, for commercial uses, static dissipative rubber mats are traditionally used, that are made of 2 layers with a tough solder resistant top static dissipative layer that makes them last longer than vinyl mats, and a conductive rubber bottom. Conductive mats are made of carbon and used only on floors for purpose of drawing static electricity to ground as quickly as possible. Normally, conductive mats are made with cushioning for standing and are referred to as anti-fatigue mats. For a static dissipative mat, see here is a sketch, you can see this diagram on right. 3-ply static dissipative vinyl grounding mat shown at macro scale. Foam cushioned bottom layer, this is in blue color. Foam cushioned bottom layer, and then buried conductive, so it's written, it's not clear, static dissipative top layer, that is, and this is buried conductive screen. So static dissipative layer, top layer, and then buried conductive screen. This is 3-ply static dissipative vinyl grounding mat shown at macro scale. Scale is macro, no problem. So you can say for a static dissipative mat to be reliably grounded, for a static dissipative mat that is shown there on top, to be reliably grounded, it must be attached to a path to ground. Normally, both mat and wrist strap are connected to ground by using a common point ground system, CPGS. In computer repair shops and electronic manufacturing, workers must be grounded before working on devices sensitive to voltages capable of being generated by humans. For that reason, static dissipative mats can be and are also used on production assembly floors as floor runners along assembly lines to draw static generated by people walking up and down. Again, in computer repair shops and electronics manufacturing, workers must be grounded before working on devices sensitive to voltage capable of being generated by humans. In computer repair shops and electronics manufacturing, workers must be grounded before working on devices sensitive to voltages capable of being generated by humans. For that reason, static dissipative mats can be and are also used on production assembly floors as floor runner along assembly lines to draw static generated by people walking up and down. Isolation. Isolation is a mechanism that defeats grounding. Isolation is a mechanism that defeats grounding. It is frequently used with low power consumer devices, and when engineers, hobbyists, or repairmen are working, or they work on circuits that would normally be operated using power line voltage. Isolation can be accomplished by simply placing a 1:1 wire ratio transformer with an equal number of turns between device and regular power service, but applies to whatever type of transformer using 2 or more coils electrically insulated from each other. For an isolated device touching a single powered conductor, does not cause a severe shock. For an isolated device, touching a single powered conductor does not cause a severe shock because there is no path back to other conductor through ground. However, shocks and electrocution may still occur if both poles of transformer are contacted by bare skin. Previously, it was suggested that repairmen work with one hand behind their back to avoid touching two parts of device under test at same time, thereby preventing a current from crossing through chest and interrupting cardiac rhythms or causing cardiac arrest. Generally, every AC power line generally every AC power line transformer acts as an isolation transformer. Generally, every AC power line transformer acts as an isolation transformer, and every step up or down has potential to form an isolated circuit. However, this isolation would prevent failed devices from blowing fuses when shorted to their ground conductor. Isolation that could be created by each transformer is defeated by always having one leg of transformers grounded on both sides of input and output transformer coils. Power lines also typically ground one specific wire at every pole. Power lines also typically ground one specific wire at every pole to ensure current equalization from pole to pole if a short to ground is occurring. In past, grounded appliances have been designed had been designed with internal isolation to a degree that allowed simple disconnection of ground by cheater plugs without apparent problem. There's a dangerous practice since the safety of resulting floating equipment relies on insulated power transformer. Modern appliances, however, often include power entry modules which are designed with deliberate capacitive coupling between AC power lines and gauges to suppress electromagnetic interference. Says modern appliances, however, often include power entry modules which are designed with deliberate capacitivity coupling between AC power line and chassis to suppress electromagnetic reference. This results in a current, significant leakage current from power lines. This results in a significant leakage current from power lines to ground. If ground is disconnected by a cheater plug or by accident, resulting leakage current can cause mild shocks even without whatever fault in equipment, any fault in equipment. Even small leakage currents are a significant concern in medical settings, as accidental disconnection of ground can introduce these currents into sensitive parts of human body. As a result, medical power supplies are designed to have low capacitance. Class 2 appliances and power supplies such as cell phone chargers do not provide any ground connection and are designed to isolate output from input. Safety is ensured by double insulation so that two failures of insulation are required to cause a shock. So these are all references and we have done with this. This page was edited on September 1st, 2000. So it's recently one, means we've updated one. We have gone through these some pages, 9 pages. So we have talked of ground here. I think we have talked of ground and we have talked of power transmission, history, building wire installations and electrode conductors, bonding, etc., etc. Properties of ungrounded systems, power transmission, electronics, circuit ground versus earth, functional grounds. Like that, we have gone through this. And I'll open then another file. I like to open this is electric ground. Now I'll open another file, and that is electric lighting arresters. Let us see what is that. And let's see what comes in. I'll close this file now because electric ground electors, electric lighting arresters, electric ground electors. We have gone through this. I think we have gone through this out. So this we will close. Now we have here with us lightning arresters. It's only 2-3 pages, I think. So it's better to go through this. Lightning arresters. Lightning arresters. A lightning arrestor, call it alternative spelling is lightning arrestor, Lightning, so it's just no difference. Also called lightning isolator. It's a device used on electric power transmission and telecommunication systems to protect insulation and conductors of system from damaging effects of lighting. Typical lighting arrestor has a high voltage terminal. And a ground terminal. When a lighting surge or switching surge, which is very similar, travels along power line to arrestor, current from surge is diverted through arrestor in most cases to earth. Here is a photo, you can see that. Power line worker performs maintenance of a lighting arrestor on an electric transmission tower. Okay, this is Canadian sketch file, no problem, whatever it is. In telegraphy and telephony, a lightning arrestor is placed where wires enter a structure. What is that? A lighting arrestor is placed. Preventing damage to electronic instruments within and ensuring safety of individuals near them. Smaller versions of lightning arresters, also called surge protectors, are devices that are connected between each conductor in power and communications systems and the earth. These prevent flow of normal power or signal currents to ground, but provide a path over which high voltage lightning current flows. These prevent flow of normal power or signal currents to ground, but provide a path over which high voltage lightning current flows, bypassing connected equipment. Purpose is to limit rise in voltage when a communication or power line is struck by lightning or is near to a lightning strike. If protection fails or is absent, lightning that strikes electrical system introduces thousands of kilovolts that may damage transmission line and can also cause severe damage to transformers and other electrical or electronic devices. Lightning produced extreme voltage. Spikes in incoming power lines can damage electrical home appliances or even cause death. Lightning, if protection fails or is absent, just think of it as saying is arresters. If protection fails or is absent, lightning that strikes electrical system introduces thousands of kilovolts that may damage transmission lines and can also cause severe damage to transformers and other electrical or electronic devices. Lightning produced extreme voltage spikes in coming power lines. In incoming power lines can damage electrical home appliances or even cause death. Lighting arresters are used to protect electrical fences, electric fences. They consist of a spark gap. And sometimes a series inductor. Such type of equipment is also used for protecting transmitters, feeding at mast radiators. For such devices, series inductance has usually just one winding. Lighting arresters can form part of large electrical transformers. Lighting arresters can form part of large electrical transformers and can fragment during transformer ruptures. High voltage transformer fire barriers are required to defeat ballistic from small arms as well as projectiles from transformer bushings and lighting arresters per NFPA 850. So we have seen that. Now let's go to certain home appliance, also referred to as domestic appliance in electric application. Appliance or a household appliance, the machine which assists in household functions such as cooking, cleaning, and food preservative. Now here is what we say. Let's go to first this. Antenna is attached to A. Let us see this picture here. A, B, C, D, E are written on this. It's a bottom, or you can say bottom. Antenna is attached to A. You can see that. That is A here. And let me just blow it up for your reference. Okay. This is A, B, C, D, E. This is antenna. Antenna is attached to A and a pipe in ground is attached to E. Pipe in ground is attached to E. Television signal can go from A to B, but not from B to C, okay, or from C to D. However, when high voltage of lighting hits, it can easily go through air from B to C in air B. So let's go components. We are talking of components. A potential target for a lighting strike, such as an outdoor television, etc., is attached to terminal labeled A. It's already there. A potential target for lighting strike, such as an outdoor television antenna, is attached to terminal labeled A in photograph. Terminal E is a long rod buried in ground. Ordinarily, no current would flow between antenna and ground because there is extremely high resistance between B and C. High resistance between B and C. And also between C and D. B and C, there is high resistance. C and D, there is high resistance. So, voltage of lighting strike, however, is many times higher than that needed to move electrons. voltage of a lightning strike however is many times higher than that required to move electrons through two air gaps. Result is that electrons go through lighting arresters. Result remains that electrons go through lighting arresters rather than traveling onto television set and destroying it. A lighting arrestor may be a spark gap or may have a block of a semiconducting material such as silicon carbide or zinc oxide. Lighting arrestor may be a spark gap or may have a block of a semiconducting material such as silicon carbide or zinc oxide. Thyrite was trade name used by General Electric Company. Thyrite for silicon carbide. Silicon carbide was named Thyrite. Hence, silicon carbide composite used in their arrestors and various varistor products. Some spark gaps are often open to air, but most modern varieties are filled with precision gas mixture and have a small amount of radioactive material to encourage gas to ionize when voltage across gap reaches a specified level. Other designs of lightning arresters use a glow discharge tube, essentially like a neon gas lamp, connected between protected conductor and ground, or voltage activated solid state switches called varistors or MOVs. Lighting arresters used in power substations are large devices. Lightning arresters used in power substations are large devices consisting of porcelain tube several feet long and several inches in diameter, typically filled with discs of zinc oxide. A safety port on side of device vents occasional internal explosion without shattering porcelain cylinder. Lightning arresters are rated by peak current they can withstand, amount of energy they can absorb, and breakthrough voltage that they require to begin conduction. They are applied as part of lightning protection system in combination with air terminal and bonding. So this is what we have gone through. This page was updated on, let me see when it is given or not. Yes, 12th August 2021. So this is also you can say lighting arresters, and then we have here. So I'll put out this. Then we have here lock of tag out. Let's go, just give me 2 minutes please. Lockout, tagout. Lockout, tagout. We have to consider this. This is also safety issue we have discussed already. Of course, many pages are there, no problem. Maybe 3 or 4 on pick. Lockout, tagout. 140, I think I can do 140 also. So it can be maintained. LOTO, LOTO, LOTO. Lockout, tagout, LOTO is a safety procedure used in industry and research settings to ensure that dangerous machines are properly shut off and not able to be started up again prior to completion of maintenance or repair work. We are going to do some maintenance work, repair work, so what's said? We have to shut off these machines. Can say lockout, tagout is a safety procedure used in industry and research settings to ensure that dangerous machines are properly shut off and not able to be started up again prior to completion of maintenance or repair work. It requires that hazardous energy sources be isolated and rendered inoperative. Hazardous energy sources be isolated and rendered inoperative before work is started on equipment in question. Isolated power sources are then locked. Isolated power sources are then locked and tag is placed on lock, identifying worker who placed it. Worker then holds key for lock, ensuring that only that person can remove lock and start machine. This prevents accidental startup of a machine while it is in a hazardous state or while a worker is in direct contact with it. Lockout, tagout. Lockout, tagout is used across industries as a safe method of working on hazardous equipment and is mandated by law in some countries. Procedure. Disconnecting or making, what is procedure is? Disconnecting or making safe equipment involves removal of all energy sources and is known as isolation. Removal of all energy sources and is called isolation. Steps necessary to isolate equipment are often documented in an isolation procedure or a lockout, tagout procedure. Lockout, tagout procedure. Isolation procedure generally includes following tasks. Announce shut off, number 1. Announce it. We are going to shut off. Number 2, identify energy sources. Identify energy sources. Number 3, isolate energy sources. And number 4, lock and tag energy source. And 5, prove that equipment isolation is effective. So there are 5 steps. Announce shut off is going to happen. Identify energy sources, isolate energy sources, lock and tag energy sources, and prove that equipment isolation is effective. Tags, you see this film or picture. Tags left in place. These are tags you can see. Tags left in place in a power plant after it was shut down, decommissioned and abandoned. So this is that one. These are tags you can see here. So let's go. Locking and tagging of isolation point. Locking and tagging of isolation point lets others know not to de-isolate device. To emphasize last step above in addition to others, entire process can be referred to as lock, tag and try. Lock, tag and try. That is, try to turn on isolated equipment to confirm it has been de-energized and cannot operate. National Electric Code states that safety service disconnect must be installed within sight of serviceable equipment. Within sight of serviceable equipment. National Electric Code states that safety service disconnect must be installed within sight of serviceable equipment. Safety disconnect ensures equipment can be isolated and there is less chance of someone turning power back on if they can see work going on. These safety disconnects usually have multiple places for locks, so more than one person can work on equipment safety. In industrial processes, it can be difficult to establish where appropriate danger sources might be. In industrial processes, it can be difficult to establish where appropriate danger sources might be. For example, a food processing plant may have input and output tanks and high temperature cleaning system connected, but not in same room or area of factory. It would not be unusual to have to visit several areas of factory in order to effectively isolate a device for service. Device itself for power, upstream material feeders, downstream feeders and control room. So it would not be unusual to have to visit several areas of factory in order to effectively isolate a device for service. So it says in industrial processes, it can be difficult to establish where appropriate danger sources might be. Example is a food processing plant may have input and output tanks and high temperature cleaning systems connected, but not in same room or area of factory. It would not be unusual to have to visit several areas of factory in order to effectively isolate a device for service. Safety equipment manufacturers provide a range of isolation devices specifically designed to fit various switches, valves and effectors. For example, most circuit breakers have a provision to have a small padlock. Most circuit breakers have a provision to have a small padlock attached to prevent their activation. For other devices such as ball or gate valves, plastic pieces which either fit against pipe and prevent movement, or clamshell style objects which completely surround valve and prevent its manipulation are used. A common feature of these devices is their bright color. Usually red, to increase visibility and allow workers to readily see if a device is isolated. Also, devices are usually of such a design and construction to prevent it being removed with whatever moderate force. For example, an isolation device does not have to resist a chainsaw. But if an operator forcibly removes it, it will be immediately visible that it has been tampered with. For example, an isolation device does not have to resist a chainsaw, but if an operator forcibly removes it, it will be immediately visible that it has been tampered with. To protect one or more circuit breakers, an electrical panel, a lockout tagout device called panel lockout, can be used. It keeps panel door locked and prevents panel cover from being removed. Circuit breakers remain in off position while electrical work is done. Group lockout. These are very important from safety viewpoint because we people have to understand at least what is required in such areas, because it's very important issue of electrical and you can say electrical transmission, lightning, etc., for purpose of shutdown maintenance. So group lockout, when two or more people work on same or different parts of a large overall system. When two or more workers work on same or different parts of larger overall system, there must be multiple holes to lock device. To expand number of available holes, lockout device is secured with a folding scissors clamp that has many pairs of padlock holes capable of keeping it closed. Each worker applies their own padlock to clamp. Locked out machinery cannot be activated until all workers have removed their padlocks from clamp. Once again, when two or more workers or people work on same or different parts of a large overall system, there must be multiple holes to lock device. Expand number of available holes. Lockout device is secured with folding scissor clamp. Lockout device is secured with a folding scissor clamp that has many pairs of padlock. There is many pairs of padlock holes capable of keeping it closed. Each worker applies their own padlock to clamp. Locked out machinery cannot be activated until all workers have removed their padlocks from clamp. In US, first let's see this photo. Lockout device, you can see this photo. Lockout device applied to a hoist brake. This prevents unintended movement of hoist. Lockout has secured with two padlocks. One is this padlock, yes, one is here. Where is the other one? I can't see, that's here. One is here, maybe where is that one? Maybe this is the other one, is it? No? I can't, no. This is one. I can't see. Where is the other one? Oh, it's here, yes, it's here. Here is this. Okay. It says lockout device applied to a hoist brake. This prevents unintended movement of hoist. Lockout has secured with two pads. Okay, now in US a lock selected by color, shape or size, such as a red padlock is used to designate a standard safety device, locking and securing hazardous energy. No two keys or locks should ever be same. No two keys or locks should ever be same. A person's lock and tag must only be removed by individual who install lock and tag unless removal is accomplished under direction of employer. Employer procedures and training for such removal must have been developed, documented and incorporated into employer energy control program. Identification. By US federal regulation, whatever number, no need, Tag must have an identification showing name of person doing lock and tag. While this may be true for United States, it's not mandatory in Europe. Lockout can also be done by role such as shift leader using a lockbox. Shift leader is always last one to remove lock and has verified safe to start up equipment. 5 safety steps that we have to understand. According to European standard EN 501101, safety procedure before working on electric equipment comprises following 5 steps. Disconnect completely. Disconnect completely. Secure against reconnection. Secure against reconnection. Verify that installation is dead. Carry out earthing and short circuiting and provide protection against adjacent live parts. I repeat, this is European standard, what it says for safety procedure before working on electric equipment comprising following 5 steps. Number 1, disconnect completely. Secure against reconnection. Secure against reconnection. Verify that installation is dead. Carry out earthing and short circuiting and provide protection against adjacent live parts. Site policies regarding lockout tagout. A site lockout tagout policy provides workers with an explanation of safety goals of policy. Identify steps required for a lockout, tagout, and advise consequences of failure to carry out policy. A documented lockout tagout policy may be required by government regulations in some jurisdictions. For example, in US, for sites regulated by OSHA rules, standards by country. Canada, for example, all Canadian jurisdictions legally require lockout for certain work. However, specific activities required for appropriate lockouts are usually not specified in law. These specifics are provided through industry standards. Canadian Standards Association's standardized CSA Z460 based on industry, labor and government consultations outlines specific activities of lockout program and is usually considered appropriate standard of good practice for lockout. All Canadian health and safety legislation places in general duty on an employer to take all reasonable precautions in carrying out this standard of good practice is usually considered a mark of due diligence. In the United States, lockout tagout in US has 5 required components to be fully compliant with OSHA law. 5 components are lockout tagout procedure, documentation, lockout tagout training for authorized employees and affected employees, lockout tagout policy, often referred to as a program, lockout tagout devices and locks, lockout tagout auditing every 12 months. Every procedure must be reviewed as well as a review of authorized employees. In industry, this is an Occupational Safety and Health Administration standard, OSHA, Occupational Safety and Health Administration standard, as well as for electrical NFPA 70E, OSHA's standards on control of hazardous energy lockout tagout, found in 29 CFR 1910-147, spells out steps employers must take to prevent accidents associated with hazardous energy. Standard addresses practices and procedures necessary to disable machinery and prevent release of potentially hazardous energy while maintenance or servicing activities are performed. It says standard addresses practices and procedures necessary to disable machinery and prevent release of potentially hazardous energy while maintenance or servicing activities are performed. Two other OSHA standards also contain energy control provisions. That's 29 CFR 1910-269 and 29 CFR 1910-333. In addition, some standards relating to specific types of machinery contain de-energization requirement, such as 29 CFR 1910-179-1-2-I-C, requiring switches to be open and locked. In open position before performing preventive maintenance on overhead and gantry cranes. Provision of Part 1910-147 applies in conjunction with these machine specific standards to ensure that employees will be adequately protected against hazardous energy. Compliance. If employees service or maintain machines where unexpected startup energization or release of stored energy could cause injury, OSHA standard applies unless an equivalent level of protection can be proven. Equivalent level of protection may be achieved in some cases through standard operating procedures, SOP, standard operating procedures, and custom machine guarding solutions that are combined to establish machine control to protect worker from a specific task. Standard applies to all sources of energy, including but not limited to mechanical, electrical, hydraulic, pneumatic, chemical, and thermal energy. Not limited to them, such as mechanical, electrical, hydraulic, pneumatic, chemical, and thermal. This is unlimited, you can say. Standard doesn't cover electrical hazards from work on, near, or with conductors or equipment in electric utilization, premise wiring installations, which are outlined by 29 CFR Part 1910, Subpart S. Specific lockout and tagout provisions for electrical shock and burn hazards can be found in 29 CFR Part 1910-333, controlling hazardous energy installation for exclusive purpose of power generating, transmission and distribution, including related equipment for communication or metering, is covered by 29 CFR 1910-269. A standard also doesn't cover agriculture, construction and maritime industries, or oil and gas well drilling and servicing. Other standards concerning control of hazardous energy, however, apply in many of these industries and situations. Exceptions. A standard doesn't apply to general industry service and maintenance activities in following situation. Exposure to hazardous energy. Exposure to hazardous energy is controlled completely by unplugging equipment from an electric outlet, and where employee doing service or maintenance has exclusive control of plug. Exposure to hazardous energy is controlled completely by unplugging equipment from an electric outlet, and where employee doing service or maintenance has exclusive control of plug. This applies only if electricity is only form of hazardous energy to which employees may be exposed. This exception encompasses many portable hand tools and some cord and plug connected machinery and equipment. An employee performs hot tap operations on pressurized pipelines that distribute gas, steam, water, or petroleum products, for which employer shows following. Continuity of service is essential. Shutdown of system is impractical, and employee follows documented procedures and uses special equipment that provides proven effective employee protection. Employee performs minor tool changes or other minor servicing activities that are routine, repetitive, and integral to production that occur during normal production operations. In these cases, employees must have effective alternative protection. In UK, there are a few instances across UK regulations that refer to lockout tagout indirectly. Use of lockout tagout is not currently enforced in UK but has been proven to be best practice for multiple UK industries. BS 7671-2008 is a regulation in UK that ensures that all wiring and electrical installations completed within whatever building is of highest standard. It also states every employer shall ensure that where appropriate work equipment is provided with a suitable means to isolate it from all its sources of energy, every employer shall take appropriate measures to ensure that reconnection of any energy source to work equipment does not expose any person using equipment to any risk of their health or safety. Provision and use of work equipment. Provision and use of work equipment. Regulations 1998 and 99 in Northern Ireland. PUWER is key regulation. PUWER, that is provision and use. P stands for provision and use of work. U stands for use. Use of work equipment regulations. Provision and use of work equipment regulation is key statute that is enforced within manufacturing industry within UK. This reinforces that employers should make all machinery safe for use, including adding additional precautions such as extra guards and safe personal protective equipment. Machinery should also be inspected at regular intervals to ensure it's in continued safe to use. There are citations within PUR, that is provisions and use of work equipment regulation. There are citations within PUWER regulations that argue use of safety devices such as lockout, tagout. However, at no point do regulations state this outright. But it does explain that lockout devices should be used to enhance safety of employees. So it may not be written in black and white under English regulations that lockout, tagout should be used. But document does mention a hierarchy of measures for standardizing safety procedures that are locked out, tagout related. But they are explained as a permanent fixture to whatever machine or tool. For instance, one of three measures mentioned is to provide protection appliances, jigs, holders, push sticks, and as a wider assumption, this could include low-tow devices. But it doesn't specifically say that in regulation. This part of regulation is more about ensuring that day-to-day workplace risks are assessed properly and thoroughly. Risks are assessed. This part of regulation is more about ensuring that day-to-day workplace risks are assessed properly and thoroughly. However, in same set of regulations, later on it states that employers should ensure that all work equipment is accompanied by an appropriate way or to isolate power energy, including an appropriate set of actions and facilities to turn power back on without creating a potential hazard for other employees. This is more aligned with American OSHA guidelines and practices and defines that lockout tagout safety movement is on rise in UK. In UK, guidelines are OSHA based and therefore pick up on American characteristics in its legislation. But in 89-55 paragraph that states that every piece of equipment must be fitted with clearly visible devices with which it can be separated from every energy source. This indicates that all workplace machinery should be fitted with permanent LOTO solutions for easy and safe lockout tagout procedures. So I think I've gone through this. We have gone through this logout tagout. We have gone through 3 files now today. We have gone through, you can say, electric, ground, electricity. We have gone through electric lighting arrestor, and we have gone through electric lockout. These are very, very responsible files for us to understand. Still, we have not completed our, you can say in this case, versus, let me see this face, yeah, it's this one. So here we have gone through electrical isolation, lighting arresters, and grounding with item number 23, 24, 25, and we have to go through warning signs, install and review process and designs to ensure that vehicle is in safe conditions. So generally you can say there's some more work here, that is warning signs, install and review process and designs, and we will just have another view of this and go through further administrative controls and all that as are given here, just to understand what more we can understand from this. We can say that's basically it's already more than 3 hours. Safety is safety, we cannot challenge it, and we have to learn from our educations. Quality required everywhere, as I said before, and safety is very important, as I said in this, that गुणवत्ता बिना सब कर्म बेकार, in Hindi it is, and quality, safety, etc. Guणवत्ता, activity in life, quality required everywhere and in every activity in life and in engineering. So we are talking this as quality of understanding safety, health, environment required everywhere during manufacturing and in construction, and also during use of products wherever. Ergonomics is a science that tells everyone about how to use available energies for doing work activities in best possible manner. So I think we have done today work. So it's already 3 hours 10 minutes. I would simply say it was a good time, at least today. Singles worked, and it's 3 hours. I think I should not waste your time. So I wanted to go to 4 hours, 5 hours, but I have my limitations. I can't subject my device to that long one time, and I hope that I could do something and you could get something that can be assumed, nothing else. It can be assumed that we are going slowly, but very specifically on these safety talks, which are very important in safety world and quality world both. And quality is also very important along with safety. If we don't keep that, we miss something. So I would take your leave now. Thank you very much.